Good morning. Thank you. Okay, since we are behind the schedule by almost 15 minutes and we have two, three programs, so I'll not take much time in setting the tone because I think already you have seen some of the things, Nukkad Natak or some programs. All you know, we are celebrating the Science Festival in collaboration with Rosatom. Rosatom is basically it's a Russian organization, just like we have DAE, Department of Atomic Energy, for peaceful application of nuclear power, nuclear energy. So I'm really happy to welcome you all to this special program, and thanks also for coming and joining this. I know schools have just reopened, and we have invited you. So keep. So we have gathered here to celebrate the Science Festival, a remarkable event occurring in countries where Russia uh, assists in building major nuclear power plants. Perhaps we all know they have been quite supportive. In India, the Russian company Rosatom is playing a significant role in constructing the Kudankulam nuclear power plant. I think you all of might have heard about this Kudankulam nuclear power plants. How many of you have visited or heard about any nuclear power plant in India? How many of you have heard about BARC, Bhabha Atomic Research Center? Yeah, I can see some hands over there. Okay. And how many of you have heard about Dr. Bhabha? You people have never heard? Or you are not, you're tired? Not raising hand. Something like that. You can do it like this. Okay, we are having a nuclear gallery, full-fledged gallery on nuclear power. First we did in 2009 and now we are renovating it. So I'll request all of you to visit and know more about, including Dr. Bhabha and how robust the nuclear program, power program of India is. Okay, so this science festival purpose is to foster interest in science, technology, engineering, and mathematics, which is we all know it's called STEM, with a focus on nuclear energy, showing how science can impact our world positively. Because nuclear energy is now has been given a green energy tag. So to commence today's session, we on nuclear power and net zero. We have with us Dr. A.P. Jayaraman. I'll briefly introduce our distinguished speaker as well. He is a renowned nuclear scientist and passionate science communicator, celebrated for his lifelong dedication to nuclear science and science education. He has made significant contributions to promoting scientific literacy and public engagement. Dr. Jayaraman has served as a nuclear scientist at BARC, as I told you just now, Bhabha Atomic Research Center, and is the chairman of National Center for Science Communicators, principal scientific advisor at HN, HSNC University, Mumbai, a member of scientific committee at the PCST network, and president of Indian Development Foundation. He is also the founder of a STEAM Academy, who is working for science popularization. And more over all of these, he is friend of Nehru Science Center, a frequent visitor, our guiding figure also. We always look towards him. So, with this brief introduction, I will request Dr. Jaraman to come on the dais. And while you people clap for him, I'll request Miss Vaishnavi from SS Sahani School to present a potted plant on behalf of all of us and welcome Dr. A.P. Jayaraman. Miss Vaishnavi from SS Sahani. Thank you, Vaishnavi. And now I will hand over the stage to Dr. A.P. Jayaraman.
Welcome, Doctor. Good morning, all beautiful minds. Dobroy Utrom to my Russian colleagues. Umeshji is a close friend of mine. So please don't trust all the good words he spoke about me. Friends always speak very good of their friends. That's what I am. I have spent 40 years in nuclear energy. That's my only qualification to be here. There's no other qualification. And I'm 80 years now. So what is the view of an 80-year-old scientist to the new generation below 15? That is what we are now trying to do that. How many of you recharged your mobile phones this morning? How many of you have got mobile phones? Have you recharged this? Yesterday, today? Okay. So we are called Homo sapiens, but now we are called Homo electronicus. Without electricity, there is no human being. Right from your mobile charger, to your electric toothbrush, to your electric iron, to your refrigerator, to your cooker, and ultimately when you die, to the electric crematorium. So electricity is the whole essence of life. Homo electronicus. That is what we are. Can somebody... Does it move? Can you make it move? I need some electronic support. Can I go to the next slide? Yes. So I told you that we are all not Homo sapiens, but Homo electricus. We use electricity. Right from our gut, doctors use it, at the crematorium, or you can see the mobile charger, we use a 4 watt electricity, you can brush take 6 watt, and your electric vehicle, which you say is a green vehicle, you use 2000 watt of electricity to charge this electricity. So that's how we all do it. I'm being dressed up to be suitable for you. Anywhere you can. They're old clothes. Yes. So our happiness increases if we use more electricity. Is it true? Then you can become the happiest person in the world by using maximum of electricity. But if you have no electricity, you are very poor. There is a relationship between the electricity you consume and your human development index. How educated you are, how much food you take, how many doctors you visit. All these things, the quality of your life, the standard of your living depends upon the amount of electricity, not you eat, but you use. So that is what we call the human development index, electricity consumption. But you will find that at some stage it stops. Look at India, we are at 0.6. Look at Russia, 0.8, far ahead of us in human development index, because they have a powerful nuclear energy program. So the nuclear energy or their ability to produce, without energy, you can't do anything. When you get up, you have to take some coffee or tea or some milk. That gives you energy. All of us are machines. Every human being is a machine. It is a 100-watt thermal machine. We produce electricity. We burn food and we produce carbon dioxide. And that is how our biochemical mechanism works. So we are all machines. We produce thermal energy, but with that 100-watt thermal, you cannot live a good life. To lead a good life, we need kilowatts of energy. That energy has to come from other sources, not from your friend, not from your father, mother. They cannot give you energy. You need energy from outside. And that is electrical energy, which we are using. Now, where does this electrical energy come from? It comes from various sources. It can come from a variety of sources. For example, generally it comes from burning coal. coal is carbon, diamond, the graphite, the pencil you write, and the fullerene you use, and the eyelash which you use, the cosmeticals, all these are carbons. So we live in a world of carbons. Not only that, we live in a world of carbons, we are all carbon bodies. All human beings are complex molecules of carbon, hydrogen, and oxygen. Nothing else. We are all CHOs. Therefore, that CHO we burn, coal. When you burn coal, fire will come out, heat will come out. With that heat, you turn water into steam. That steam will turn a turbine. It will produce electricity. That is the general way of making electricity. But sometimes you can also make electricity by the falling of the rivers. When there is a huge waterfall with a lot of energy, it will produce hydroelectric. Then you can also put your solar panels. You can do it from that. And the wind is rotating. You can keep fans over there and collect electricity out of that. Then you can burn not only coal, you can also burn methane and natural gas. But there is one thing which you saw the drama over here, the nuclear power. New and clear power. Absolutely new. Absolutely clear. No, we were all made to be afraid of nuclear power. Throw away your fear. Get out of that radiophobia. Nuclear power has saved more human lives than it has done any damage so far. So that's where the world is. Now, if you burn coal, I have 30 minutes, so you can mark the time I stop. 11:40, I'll stop. The point is, there are greenhouse gases. They're all red gases. They're called greenhouse, but they're absolutely red in color. They're very toxic. So toxic, the simplest one is called methane. 1 atom of carbon, 4 atoms of hydrogen, methane. 1 atom of carbon, 2 atoms of oxygen, carbon dioxide, the one which we breathe out. Every day I take food and I produce 1 kilogram of carbon dioxide. All of you will produce carbon dioxide. So we are thermal machines and we are carbon dioxide producers. That's the problem. Then there is another gas which is called methane. 1 atom of carbon, 4 atoms of hydrogen. Instead of 2 atoms of oxygen, we have 4 atoms of hydrogen. And that is 28 times more toxic than carbon dioxide. Luckily, we don't release much methane. I'll show you how the cows and buffaloes and horses and donkeys, they release more methane than human beings. So these are the various 7 deadly red gases which you should keep away from. But look at the cow. This is a methane producer. I am a carbon dioxide producer. This cow produces not only methane, it produces carbon dioxide. Earlier, scientists have a doubt. Is the cow giving out methane from the mouth or from the rectum? So scientists worked on the problem and they found out there is more methane coming from the mouth rather than from the back. So this is the show of methane gas. And if you want to make a world free from methane, you'll have to remove all the cows. Can you do that? No. A cowless economy is no economy at all. You can't live without drinking milk. Therefore, you must go for nuclear, for carbon dioxide equivalent removal of what the cows do. So carbon, that is the main word. Everything. Hydrogen, helium, lithium, beryllium, boron, carbon. When you come to carbon, stop. In the periodic table of 118 elements, beginning with hydrogen, ending with organethone, you will find this fellow, carbon. And you must burn this in your textbook. Now you will be learning more about it. Carbon dioxide, net zero carbon, carbon emission, carbon sequestration, carbon stock, and carbon tax. If you do something wrong to the environment, you'll have to pay a tax for it. And that is called the carbon tax. So what is called net zero? We all know zero. Zero means nothing. If I get 0 marks in my examination, I am good for nothing. But if I get 2 zeros and 1 to the left, I get 100 marks. 1 here and 2 zeros to the right, I am on top of the world. So the difference between 0 and 100 depends on where your 1 comes in. So you can be net zero if the cow is releasing, say I am releasing 1 kilogram of carbon dioxide and I have kept 2 plants. That plants will take 1 kilogram of carbon dioxide per day. I am carbon neutral. Carbon neutrality means the amount of carbon dioxide you produce and the amount of carbon dioxide removed by you is equal. Then you are net zero. So the word net zero you will be learning in great detail, not only in physics, chemistry, and biology, but also in accountancy, in commerce, and in business, because you will be paying carbon taxes. So why this nuclear energy all the time? Once upon a time, long, long ago, in ancient times, very olden times, there was an Indian saint by name Kanada. Kana means particle. This is called the philosopher of particles. He said everything in the world, everything in the universe is made up of small little particles, and they are called atoms. That's all he said, nothing more than that. And other people made fun of him. This fellow says everything is made up of particles. I find water flowing. Water is not particle. So they made fun of him. But he said nothing doing. Everything is made up of atoms. So that's called Kanada. But he never knew the structure of the nucleus. But then came a great man, Dalton. In standard 7 and 8, you would have studied Dalton's atomic theory. Everything is made up of atoms. Atoms have weight, atomic weight, and you will calculate that. That's called Dalton's. So Dalton was carrying the atom on his head, and all students now are carrying atom in their brain. And there was a great man, Mendeleev. Dmitry Ivanovich Mendeleev said that all these things in the universe are made up of elements. And there are, when he said it was 64, but now we know we have 118 elements in the periodic table. Now there is another lady, Marie Curie. There are women of nuclear science. In fact, nuclear science is the field where women have shown the best. Even today, by 2025, the 50% of the nuclear scientists of the world will be women. That's what the International Atomic Energy Agency is trying to do that. So this is the first lady who found out radioactivity. There are some atoms which are heavy, and when they are heavy, they give out some energy. So that energy-giving atoms are called radioactive atoms, and we call her the lady of radioactivity. Then came Liz Meitner. She said, these heavy atoms can be split. I can break them into two. That's called the splitter lady. This is the lady who ushered in the nuclear age. None of us would have come in today's state but for Liz Meitner. She said, take uranium, heat it with a neutron, it will split into barium and krypton. Not only will it split into barium and krypton, it will also release some energy, and it will release 3 neutrons. That energy which comes from the uranium splitting is, according to Einstein's equation, E is equal to mc squared. But the most important thing is, hit with 1 neutron, 3 neutrons come. 3 neutrons will hit 3 uranium atoms. There will be 9 neutrons. 3, 9, 27, 81, there it will run. That is called the fast flaming, like fast fashion. That is the chain reaction, which is the basis for the creation of nuclear. And that's how it looks like. You have barium, krypton, uranium-236, the chain reaction details, which you will study better in, this is what I told you, in every nuclear reactor, uranium splits. Of course, you can also make plutonium split. You can also have thorium converted into uranium. That's all advanced technology, which you will learn when you go to higher classes. And the 2 great men of India, Homi Bhabha and Vikram Sarabhai. Atomic energy or nuclear energy was brought into India by Homi Jahangir Bhabha. And he had set up a training school in which we all studied and learned atomic energy from him. The last class, he died in 1965 in an air crash. The last batch was 1964. I was a fortunate student in the 1964. I took my graduation certificate from him. And immediately after that, we had Dr. Vikram Sarabhai. Homi Bhabha said that atomic energy is not only useful presently, its future is very great, very bright. He said that large amounts of thorium in the monazite sands of Kerala, which is just but thorium-232, can be converted by neutron radiation to uranium-233, and that will be the fuel of the future. So we have designed a rugged philosophy of 3-tier atomic energy program, thanks to the visionary spirit of Dr. Homi Bhabha. And we have the reactors here. And India is a nuclear proud country today. You can see the various nuclear reactors we are opening. We have a large number of reactors. And of course, this is the head office of the Rosatom group over here, because they are the leading nuclear business machines in the world, spreading the message of nuclear energy throughout the world. And there's a large contribution. They will be greening the world. And we have excellent relations. Our Prime Minister, in consultation with Mr. Putin, he has been visiting the atomic energy establishment also. So nuclear power is the future. Today you will find this is where we stand. Today we are just less than. We have about 440 nuclear reactors working all over the world. but we still produce only 10% of the total power. Another 90% is produced by coal and hydro and all renewable energies. We have miles to go. But now we will be running at a fast rate, and nuclear energy will be overtaking all other sources of energy very, very fast. And beyond that, at the moment, we are splitters. Now we'll be jointers. We'll split uranium, produce barium and krypton. Now we will put deuterium and tritium together and create the artificial sun, which China has already done. So fusion will be the next frontier. You're all very young. You will be working not on fission energy. You will be all working on the fusion energy. So remember, the message is this: the nuclear renaissance has come. There is no future without nuclear. And net zero, if you want to reduce the damage and harm you do to your environment, the only solution is nuclear. So think of the nuclear every day, learn all about nuclear technology, try to be a nuclear scientist, and contribute your might and best to the world. Thank you. I stopped in time.
Thank you, sir, for this beautiful lecture and those insightful words. Now it is my pleasure to introduce our next speaker, Ala Udalava. She is a professor in the Department of Nuclear Physics and Technologies at Obnings Institute of Nuclear Power Engineering, National Research Nuclear University, MEPhi. So let us welcome Professor Udalava with a warm round of applause.
This is for
Yes. I would request Ms. Aditi from SS Sahani School to welcome Ms. Udalava with a small token of appreciation from Nehru Science Center. So we are all eager to learn more about nuclear physics from you, ma'am. The stage is yours.
Good morning, dear friends. I'm very happy to be here and participate in this science festival. And really, it is a very interesting event to be in India and see how other people are also interested in nuclear energy and nuclear power engineering and all these fields. Thank you, the previous speaker, for a brilliant introduction of many issues really important for new generation, for children. And I hope I will add a bit of more nuclear technologies, but I am sure it will be clear. So shortly about nowadays development, new technologies and current trends in the nuclear power engineering. In the introduction, it was said that I am from, okay. Maybe it is not on. Okay, yeah. So I represent here National Research Nuclear University in Russia, Moscow Engineering Physics Institute. The headquarters is located in Moscow. And please raise your hand if you know what is Moscow. Do you know Moscow city? Please raise the hand if you know. Don't be shy. Great, great. Yeah, this is capital of Russia. I'm sure that you know. Our university is a leader in nuclear education in the Russian Federation, but actually we have a consortium of such universities. And as Russia is a large country, you know, we have branches in other places in Russia and also abroad. And I am from the largest branch, which is located in a small town called Obninsk. And actually, I hope that I will see at least one hand or maybe more if you heard about Obninsk. Have you ever heard about such place? No, no. So you should know that this is exactly the place where the first in the world nuclear power plant was launched. Yeah, and I live exactly in this town, and we have a lot of students there from foreign countries and from India, by the way, also. And this first in the world NPP was connected to electrical grid in 1954. So if you know math, yeah, this year we celebrate 70th anniversary. It is great event. Thank you. It is great event for scientists of our town, of Rosatom State Corporation. And actually this is a celebration of the global society involved in nuclear power engineering, because this is really an era of nuclear power engineering. So 70 years of active work. So it was the first, right? And since then, nuclear power developed, and these facilities have been constructed around the world in many countries. And as it was mentioned in previous lecture, yeah, we, humankind, need more and more energy, more and more electricity. You can see, like from this slide, that at the beginning of nuclear era, it was global consumption of energy, of electricity. And by 2018, it increased nearly 5 times, yeah, 4.5 times. Mind the share of nuclear electricity, yeah, it started from very low amount. By the way, this is it the value for India now? I think this is the figure for India, nuclear share of India in other electricity sources. And by now, this is about 10%. So we see the growth of demand, the growth of consumption of nuclear energy, and of course, there is a development of these technologies. Today, we have about 440 nuclear reactors producing electricity, generating electricity around the world. Okay, they are located in about 32 countries. And maybe you've seen that 10% on average for the world is not very large amount, yeah, not very large contribution into electricity generation. But there are at least 15 countries for which this share is much higher and very important. There are countries with more than 50% generation made by nuclear, and others with also very high contribution of nuclear electricity. You see in color on this map, we see the countries where nuclear power plants are used. And, well, not the whole world, but essential part of the world participate in this and own such technologies. Also interesting to see the operating experience, 20,000 reactor years. Think about it. We now live in the year 2024, yes, only 2000. But world experience of nuclear electricity generation is 20,000 years. So really, this is a good experience, large experience. This is way full of discoveries, sometimes mistakes, a lot of lessons learned. And now we are quite sure in our knowledge and skills. Today, a lot of countries would like to develop nuclear electricity, nuclear power engineering better. Maybe you've heard about some shortage of these developments in previous years, maybe not in this audience, because of different political issues, there was some shortage, but now the world recognizes very well that we can do without nuclear technologies. And the developed countries who already had these technologies continue and improve these things, and many newcomers in the nuclear technologies are around the world now. We all understand why we need it. Yeah, like the three main reasons are shown on the slide. We need more and more energy with our growing population. Fossil fuels are going to end soon. And also environmental challenges also make us to develop better, clean, green energy sources. Oh, well, so today you see nearly 60 new reactors are under construction around the world in 18 countries. And some of them are really newcomers. India, by the way, is not newcomer. Yeah, India has very good experience already of nuclear technologies and nuclear fuel cycle. You are on the very large position in this field, but we have now many newcomers also. Talking about Russian Federation, we have today 11 nuclear power plants. It is not a large number, but just we don't need more. We are not about the amount, we are about the quality. Sorry, yeah, not quality, but quantity. We develop new technologies. This is why we are not interested just to construct new power plants. We'd like to construct pretty new, with new reactors, with new ideas. You see in Russia, we have about 20% of electricity supply covered by nuclear. And mainly, of course, in European part where we have denser population. We construct some new plants just to replace the old nuclear power plants which are decommissioned already or are going to be decommissioned. Okay, and I'm not going to talk about design of nuclear reactors in details, but you can understand that there are a lot of different designs developed by different countries, different scientists. And we all now try to improve these projects so to make them economically viable, easy to construct, longer life period, and so on. And Russian project, which is now considered as a reference project for foreign countries, is called VVER 1200. VVER stands just for the type of reactor. This is water energetic reactor. And 1200, this is thermal power of 1 unit of this reactor. And this is so-called generation 3+ nuclear reactors, which have improved characteristics of safety, reliability, and so on, just much better in construction. With the construction of this new reactor, first was launched in 2016, we opened new era in exploitation of such facilities. And today, when we are sure, Russian scientists, when we are sure in characteristics and safety of this reactor, it is proposed for other countries, our partners who are interested in building of such facilities. Today, several nuclear power plants of this design are under construction or nearly ready. Well, the first one, Belarusian NPP, with 2 units, is in operation already. Aku NPP is also ready to start. And in Rupur, also large nuclear power plant is in process of construction with this reference reactor, VVER 1200. Well, so it was talk about large nuclear power plants, and it is understandable. Yes, they give a lot of energy, and many countries are interested in it, like India, because you have large population and developed industry and so on. One of the current trends in the world is the construction of small reactors. They are interesting for some remote locations, for example, for islands, for island countries, or for some specific purposes, like, for example, mining in remote regions also. This is also the line of technologies which is under development in Russian Rosatom Corporation. And we have now projects of such reactors. And we started already construction of small model reactor in our Siberian region. If you heard about it, yes, this is quite cold and harsh climatic conditions there. And this small reactor will help to local territory to cover all needs in energy. Interesting that idea of small nuclear reactors grew from icebreakers. Yeah, have you heard about nuclear icebreakers? Nuclear powered icebreakers, do you know about these ships? Yeah, in India, you don't worry about ice and wind. Yeah, this is Russian case. But actually, the fleet of these icebreakers will help to the whole world, including India, in trading, because we can use now Northern Marine Route to bring goods from different parts of the world. And this route is better, shorter, and so on. And Russia is the only country in the world which has a nuclear-powered icebreakers. Today, we have 8 in service and 3 new under construction of new line again, new projects. Isn't it beautiful? I like this picture. And also we have a new design projects also under construction. These new machines which look like science fiction. Yeah. This icebreaker hasn't existed yet. Yeah, this is the only slide in my presentation, which of device of facility which hasn't existed yet. All others are real facilities, but soon we will have it. It's already on the way. Next step of development of these technologies are floating nuclear power plants. This is example of a small reactor, a small nuclear power plant, and this is even mobile, yeah, as this is floating. Floating NPP academician Lomonosov, this is quite famous scientist in Russia, now operates in our Siberian region also. It is at the bank there and gives electricity, thermal energy, hot water to this remote district. This project is also very interesting because it's possible to modify the project for desalination of water. Also, this is global problem of fresh drinking water in the world, yes. And these facilities can also help with it. You see, the possibility is enough to cover needs of large city. Well, maybe not very large, 200,000 population. We can cover with this very small machine, which is just a bit more than me in size, reactor vessel. Well, then I'd like to mention one more thing about new trends in nuclear power engineering. You know, everywhere they say that the main problem of nuclear energy are radioactive wastes and spent nuclear fuel. Yeah. Well, our partners from other fields working with fossil fuels or with wind and solar energy, they say nuclear is bad because of radioactive wastes. The matter is, most countries in the world use so-called open fuel cycle. How does it work? Yes, so there is an initial stage where we have mining of uranium or other, maybe thorium, yeah, and fabrication of fuel, nuclear fuel for nuclear power plants. Then this fuel is used in nuclear power plant. It is like burned there, and we have electricity, yeah, in our electrical grid. And then spent fuel and also radioactive wastes should be reprocessed somehow. But most countries don't do deep reprocessing. and just store these wastes or think about final disposal for a very long period, for maybe millions years. And this is, of course, bad idea because we are going to have this threat for a very long period. Russian decision, Russian solution is to do closed fuel cycle. So what we do, we take this spent nuclear fuel, reprocess it so that a part of uranium is extracted, the part of uranium which wasn't used in previous stage, and it is taken again for fuel fabrication. Another radioactive isotopes like plutonium or some others are taken for fabrication of nuclear fuel of new type, which is used in another reactors, breeders. Breeders is a fantastic thing because they not only give us energy and electricity, but they produce fuel for nuclear reactors of previous generation. I don't know, this is something which people can believe. Yeah, we produce fuel in nuclear reactors for another nuclear reactors. And this way, we will not need a lot of uranium for future because we have a lot of resources in spent nuclear fuel. And this is so-called closed nuclear fuel cycle, where wastes are very, very low in amount. And in the world, not many countries or specialists maintained this idea and reached any successes. But in Russia, we have already several breeders. Yeah, these are reactors which use not thermal neutrons, which were discussed in previous lecture also about fission reaction. These reactors use so-called fast neutrons. And BN abbreviation stands in Russian for fast neutrons. So yeah, these two commercial reactors are already in operation, and they are the largest, the most, I don't know, important in the world, and there is no other countries which have such achievements in closing nuclear fuel cycle. So these are some new trends, developments, and so on, and I hope it is interesting for you, like for me, and will involve you in future in this field. Of course, for successes in these trends, in these purposes, in achievement of these purposes, we need new people, new generation of reactors, need new generation of stuff. And these are going to be your generation. So please come to nuclear education in India, in Russia, in other countries, for example, in our university. You're welcome. Thank you very much.
Thank you so much, ma'am, for this informative and beautiful lectures. So now we'll move on to the highlight of today's event, the panel discussion. Just before that, I would quickly call on stage the participants of the street play who has demonstrated a beautifully created street play just outside the auditorium gate. I'd request Mrs. Katrina Makarova to give away the gifts to the students. So may I call on stage the students from Bai Kabibai English School and Junior College, Mr. Ayush Makwana, Yash Yadav. Please come. Just a second. After that, yeah, you just read okay. Mr. Yash Yadav, Ms. Shabnam Sheikh, Ms. Sejal Ghag, Ms. Tanisha Singh, Mr. Bikrant Gholap, Mr. Bharat Lambor, Mr. Prashant Gupta, and the teacher in charge, Mr. Ajit Dabe. Congratulations, team. It was a really good, very good performance. Thank you all. Please give a big round of applause for the team. अरे वो बैक पे लेके जाना वो क्लियर करके लेके जाना ठीक है ठीक है Thank you, the team from Bai Kabibai English School and Junior College. So just we'll take some time to set up the stage. Before that, I would like to welcome Mrs. Katrina Makarova. She is our collaborator from Rosatom, Russia, and she is attending specially this event, Science Festival India 2024 from Moscow, Russia. She arrived yesterday and she is continuously here with us, supporting us and be here with the participants and conducting the events. So I would like to request Ms. Ariba from SS Sahani School to welcome Mrs. Katerina Makarova on behalf of Nehru Science Center. Yeah. So before moving, I'd request Mrs. Makarova to deliver the vote of thanks.
Good afternoon to everyone. Good afternoon. On behalf of Rosatom and our organization, Energy of the Future, I would like to thank a director of Nehru Science Center in Mumbai, Shri Umesh Kumar Rustagi, and Dr. Anidita Amandal, creator of Nehru Science Center in Dubai. And the whole team and the whole educational team of the Nehru Science Center for partnership and for arranging this beautiful event here. The Science Center has become a place where people, huge kids and families came and learned more about not only nuclear power, but also about Russia and Moscow. And we are really happy to be here to be part of this event. And I hope that today's lecture will help you maybe not only to learn about nuclear, but maybe to think about your future profession and to regard nuclear area as a possible way to get education and to learn more about science. We also are very happy to be here today as Nehru Center celebrates its 39th anniversary. And it was really, I was personally really impressed by the center, its exhibitions and development. And we really would like to continue this kind of tradition and I hope that we will have another science festival next year. So thank you very much. Thank you all. Thank you to the director, to Dr. Anindita. Thank you for the